in this, let me take two problems, one from old gate and another from old IAS. Both are very good problems. Now, see here in this problem, 220 volts by 400 volts 50 Hz transformer operates on 220 volts 40 Hz. Okay, so with secondary winding open in the sense secondary current will not be there, so only in primary no load current will be there, which will contain both hysteresis component and eddy current component. Now the eddy current loss and hysteresis loss variation we have to find. Okay, now see here, voltage is same. Okay, in both cases voltage is same. Now the moment voltage is same, eddy current losses will be decided by only voltage. So eddy current loss directly proportional to voltage square. Voltage is constant, so eddy current losses will be constant. Okay, and second thing is voltage is constant and frequency of 50 Hz has been reduced. So as we discussed previously, hysteresis loss directly proportional to B max to the power of X F. Okay, now this equation should be used when B max is constant. Okay, or directly proportional to V by F. B is directly proportional to V by F. Directly he did not give any what is Steinmetz constant, so let me take 1.6 into F. Okay, so directly proportional to voltage to the power of 1.6 F to the power of minus 0.6. Now voltage is constant in this particular question, so directly hysteresis loss is directly proportional to F to the power of minus 0.6. So if frequency is reduced from 50 Hz to 40 Hz, frequency is reduced, voltage is constant, frequency is reduced, so hysteresis losses has to increase and eddy current losses remain same. So hysteresis loss of transformer increase while eddy current losses remain same. So answer should be C. Let us take one more question, which is old IAS. Okay, beautiful question. In this, two transformers X and Y with identical ratings and dimensions have 0.8 mm and 1.2 mm thickness laminations respectively. So my thickness of laminations are changed from 1.8 mm to 1.2 mm. Now, if Rm and Xm are the magnetizing branch parameters in the equivalent circuit, then means variations of Rm and Xm. As I discussed in my previous session, the moment anything is non-linear, for example, we derived shunt branch. This is going to be R0, we said, and X0 also we discussed. And the moment these parameter variations, the moment these are representing nonlinear properties, automatically variations in R0 and X0 will happen. Okay, so it is not like network theory, resistor and inductor. It is like R0 and X0 are representing properties of magnetic property and electrical property of a magnetic material. Okay, so R0 X0 values will vary. Now let me draw the phasor diagram, whatever we discussed previously. So this is going to be pi naught, this is going to minus E1 or plus E1, whatever it may be. Okay, now my hysteresis loss I0 because of hysteresis and eddy current component is this, such that my no load current component is I01 we discussed. Okay, now out of I01 it will be I mu, it will be IW. Now IW will flow through R0 because IW and V1 are in line, and I mu will flow through X0 because V1 and I mu are 90 degrees. My current is lagging behind voltage by 90 degrees. Okay, now if you closely observe, see here, depending upon hysteresis only, I mu magnetizing component of current will be decided, but because of both hysteresis component and eddy current component, because of both components, IW will be decided. Okay, now come back to 0.8 mm and 1.2 mm thickness of laminations. So if you increase thickness of laminations, eddy current losses will increase. Okay, now if you increase thickness of laminations, did they say anything about magnetic property? No. Okay, did they say anything about relative permeability variation or flux density variation? No, he did not say anything. So everything is going to be constant. Now means his focus is only eddy. So the moment eddy current losses, definitely 0.8 mm to 1.2 mm thickness of laminations are increased, means that eddy current losses will have to increase. But it don't have any effect on hysteresis. So depending upon hysteresis only, magnetizing component of current will be decided. Okay, and hysteresis is not disturbed here, so I mu will not be disturbed. Okay, so I mu should be same, means that x naught also will become constant. Okay, so in this B, xm values of in both are likely to be equal. C, okay, so means either B or C should be right answer. Now let us think of R naught. Now again, in this question, did they say anything about hysteresis or flux density and all? No, magnetic property is untouched in this question. So magnetic property is untouched in the sense this particular I0H is going to remain same, I mu is going to remain same, so x naught value is going to remain same. Now what about eddy currents? The moment you increase thickness of laminations, eddy current losses has to be increased, means that this IE component will be increased. Okay, so if you increase thickness of laminations, eddy current losses has to be increased. Hysteresis losses, he did not touch that particular point, so hysteresis losses will remain same, eddy current losses will be increased, so total core loss will be increased. Now that total core loss in the physical transformer, practical transformer, has been modeled as power absorbed by resistance R naught. So power absorbed by resistance R naught should be increased. Okay, power absorbed by R naught should be increased for a given voltage, because this is going to be voltage V1. Okay, so voltage is not changing. Okay, so for a given voltage, power absorbed by R naught should increase. Why? Because hysteresis losses are going to be same, eddy current losses are going to be increased because of increase in thickness of laminations, so total core loss has to increase. In the sense, power loss or power absorbed by R naught is nothing but core loss representation, so power absorbed by R naught should increase. In the sense, V square by R should increase, V1 square by R naught should increase. For a given voltage, this should increase, means that R naught should reduce. In the sense, R naught at 1.2 mm thickness lamination should be less, R naught at 0.8 mm thickness lamination should be more. So in between these two, RMF X is likely to be higher than RMF Y, so answer should be B. Okay, this is actually very beautiful question.